Hi guys, welcome to Energetic Coder's YouTube channel. In this series I want to talk about material creation inside Unreal Engine. And if you don't use Unreal Engine, the course is also helpful for you because I will talk about the mathematical concepts and material concepts, and you can use the concept inside another renderer, for example in Unity, Blender, Maya, or every software you use. Okay, let's start and talking about the PBR in the first lesson. What is the PBR? PBR is a new method for simulating the light interaction with the surface. Okay, it is very more accurate than other methods, for example traditional method, but in the 2D industry all of the software uses using PBR. Okay, let's talk about the different maps inside PBR. For simulating different aspects of a surface, for example bump and dent, we use normal map. For the roughness or smoothness, we use roughness or glossiness map, and we use different maps for simulating different aspects or different specifics of the surface. Okay, it's important to know that the renderer engine knows the white as one value and knows the black as a 0 value. The most software, for example Substance Painter, when you are painting a model, automatically defines that and you just export the maps. But it is important you know that the black is 0 and white is 1. Okay, let's go to the PBR material PDF and let's talk about different maps. Before that, we have two terms here, diffusion and reflection. Diffusion means when light hit the surface, it penetrates to the surface, and this means diffusion. And if the light reflects from the surface, this named reflection. It is good to know about the diffusion and reflection, and you know that what is diffuse and what is the reflection. Okay, let's talk about different maps. We have two very similar map, Diffuse and Albedo here. In the Diffuse map, we have the color of the surface also in the Albedo, but there is one big difference here. If you take a look at the Diffuse map, we have some dark areas, some shadows of the edges of the rock, but here we have no shadows or no dark areas, and in the technical term we have no ambient occlusion in Diffuse map, but we have no ambient occlusion in Albedo map, but we have ambient occlusion in Diffuse map. Before talking that, let's you know what is the ambient occlusion. Ambient occlusion is a grayscale map or white or black map which contains lighting data. If you take a look at the wall edge in the real world or real environment, you can see some black areas, and in the black areas or can be simulated by the ambient occlusion. If you take a look at here, we have one rock ambient occlusion map here, and you can see around the edge we have a very dark areas, and this is simulated by the ambient occlusion. In the 2D industry, they don't use the diffuse map because it's not very appropriate for different lighting conditions, but in the Albedo map we have no lighting information or ambient occlusion information, and it's better for quality of the material. Okay, I have talked about the diffuse or Albedo, I have talked about ambient occlusion, and there is another map very similar to AO or ambient occlusion map with the cavity map. The cavity map is the AO map with a very short trace distance. I will talk about the cavity map in the next lesson, but if you know if you want to know that here, when you're using a very detailed shape, for example a skin, for example like the bird's head or something very detailed 3D model, you should use cavity map instead of AO map for simulating the ambient occlusion. Okay, let's talk about the reflectivity or roughness. Roughness and glossiness, in another term named microsurface. This is a roughness or glossiness. It's another term for using the roughness and glossiness. What is the roughness and glossiness? Glossiness is a roughness. For example, if you have a shape or have a material with roughness at 1, you have glossiness of 0, or if you have the roughness of 0, you have glossiness of 1. As you can read here, the term gloss and roughness are interchangeable. They are simply inverse of each other. So if your software calls gloss, like Marmoset toolbag, but there is only a roughness map provided, simply inverting the software. You can invert the black and white color, and in the very inverting, you have if you invert the gloss, you have roughness. If you invert the roughness, you have the gloss. Very, very simple. Let's take a look at the roughness map. Okay, the roughness input controls how rough or smooth the material surface is. Okay, as you can see here, we have roughness from 0 going to 1, and you can see we have very smooth object here, and we have very, very, very rough object here. Okay, it is very, very simple. You can use that inside the engine, and you can see here we have the representation of the roughness value, and here we have just 3D objects. Another map is the reflectivity. For the reflectivity inside the PBR workflow, we have specular and metalness. There is a little difference between specular and metalness. Let's take a look at the metallic map and specular map here. Let's open the this documentation inside another browser, for example Chrome browser, for better loading that. Okay, it's completely loaded, and let's here we have the metallic. The metallic input controls how metal-like your surface will be. Non-metals have metallic value of 0. It is very obvious from the name. When you want to simulate the metallic surfaces, you should use the metallic value, and it is 0 in default for other materials. As you can see here, we have metallic from 0 to 1 here, and if I drag this slider, you can see the metallic and non-metallic. And if you have the brushed material, metallic, very, very smooth metallic material, you can change the metallic value to 1, and you have a fully metal value, very metal material here. But if you don't have a spec material, or you want to have very, very reflective non-metal material, okay, it's reflective and it's metal material. But if you don't want to have a plastic reflective plastic material, you should not use the metallic. You should use the specular. If you take a look at here, we have this object, and if I increase the specular value, you can have a very, very reflective non-metal surface. Okay, a specular for non-metal surfaces and non-metallic surfaces. If you want to simulate the reflection on the non-metallic surfaces, you should specular. But if you want to simulate reflection on the metallic surfaces, you should use the metallic value. Okay, very, very simple, and I try to explain that very carefully. Hope you understand. Okay, the next map is a translucency and transparency. If you take a look at this map here, we have a black and white map here, and translucency means when lighting. Okay, here you can read that. Transparency is a term used to describe a surface ability to block or allow the passage of the light. When you have a transparent shape from transparent model, the light can penetrate inside the shape and go over the shape, okay, and go over from other surface. For example, penetrating from one side and crossing from other side. Okay, for example, a brick would be an object that has no transparency, while a stained glass would be an object that has transparency. We have one value, we have the opacity of 0 here, and you can see it is very opaque object, and we have the opacity of 1, and this as you can see, this is not transparent on the bottom side. Okay, another one is the normal map. A normal map is a 3D dot 3 map, is a RGB red, green, and blue map for simulating bump and dents inside material. I don't want to talk about the normal map here. I will talk about the normal maps completely in the next lesson in detail. It is enough to know the normal maps are maps for simulating the bump and dents and the details on the map, and I will talk about them in detail in the next lessons. Okay, what is the Fresnel? You have here the Fresnel name inside the computer graphics. In computer graphics, the word Fresnel refers to differing reflectivity that occurs at different angles. If you take a look at here on the this class or this metallic shade, you can see around the edge we have more reflectivity. Okay, as you can see here, you can take a look at the graph. We have some reflectivity here, and around the shape, you can see we have more reflectivity. Okay, this specific named Fresnel. Okay, and the more reflectivity around the edge mean Fresnel. Okay, another term mean refraction. If you read this here, refraction is the term used to describe the change in direction of light wave due to a change in its transmission medium. In other words, when lights come in contact with certain surface, like water or glass, the light will get slightly bent because this surface. When light penetrates to the water, it changing the angle will be changed, and this means refraction. And for simulating the reflection, you should use IOR or index of refraction. For example, index of refraction of water is 1.033. Index of refraction is an optical measurement that can be used to tell you exactly how much light will be bent when you light proported from one medium to another. Okay, I will talk about IOR or refraction in the next lesson in depth. I want to just introduce these terms in the first lesson, and I don't want to talk too much to confuse you. And the last two terms I want to talk about them is subsurface scattering and energy conversion. As you can see here, we have one hand without SSS or subsurface scattering, and one hand here with SSS. As you can see, when you put light on a body, you can see some light penetrate into the surface, and this is a diffusion. If you remember, I talked about diffusion. It is some kind of diffusion here, and this named subsurface scattering. When you looking at the candle, you can see we have subsurface scattering, and the light penetrated to the candle. For example, light penetrated to the hand. This named subsurface scattering. You can Google that, and I will talk about the subsurface scattering in another lesson through the course. And don't worry about the exact practical usage of this material. I will talk about them. And the last term is energy conversion. The concept of energy conversion states that an object cannot reflect more light that is received. Okay, the it is very simple, and it is not important for creating material, but it's good to know, like the diffusion and the reflection. The concept of energy conversion states that an object cannot reflect more light than it receives. Okay, very good. I have named the documentation for this for a PDF file I have provided. You can check it out, and also you can download this PDF inside the description of this video in my YouTube. And thank you for your watching. If you want to support me, you can subscribe and support me on Patreon. Thank you very much. Bye to the next lesson.